So here we're saying this math teacher, teaching students calculus before they attend university may significantly benefit them. So already I'm paying attention to this word may. Like, okay, there's a lot of things that may happen in life, right? Like taking the LSAT may help you get into law school, but also may not. But here we're saying, hey, teaching them calc before they attend a university may significantly benefit them. But then we have this point where we are changing directions, and it's like, yet, if students are taught calculus before they are ready for the level of abstraction involved, so if they're taught this before they're ready for just the chaos that's going to happen, they may just abandon the study of math altogether. So we have like a little bit of a conundrum here, right? Where we're like, well, we want to help them, but if we do it too soon, we actually might hurt them. So, which is another indicator where we're saying, so if we're going to do this, we must make sure that they can handle the level of abstraction involved. So our conclusion here is this last sentence. And our reason here is because, what is our reasoning here, Nicole?
You must make sure they can handle the level of abstraction involved so that they can benefit for moving on to calculus and the university.
Well, why, yes, that's the ultimate goal. But why must we make sure that they can handle the level of abstraction involved?
So that they're successful in the university.
Yeah, well, I think there's a step in between those two things. Like, why do we care that they're able to handle, like, we want to teach them calculus so they're successful at university.
Oh, so they don't give up.
They don't give up, yeah. So that they don't abandon the mathematics altogether. I think that as a teacher, I think that this is a great argument. And I'm like, on my strength meter, I'm like, yeah, this is like all the way over here. But unfortunately, it's not completely valid. It's not all the way to that rock. And where's the gap at? So I want to think about, why is this argument weak in the first place? Angelica?
I'm thinking that just like, it's not like the word made, that just because it can help them doesn't mean it will, or it's going to push them to be successful. It's just going to give them a better chance.
Okay, why else is it weak? Katie? Or Katie might be gone. Zach, why else is it weak?
I was on mute. They're just like assuming that if they abandon it, then like they're kind of like they won't, get with the program type of situation. I'm having a hard time today just making it.
You're fine. You've been studying all morning. You're probably like, this is my last thing for today. Well, do we care? We have to be critical of these arguments, and we have to like start like, being like putting like eliminating our emotions. And do we care if they abandon the study of mathematics? What if we were super tough people and we're like, you know what, we only want to help those that can really succeed, the 1% of math people in the world? Do we care that some students that can't handle it are going to abandon the study of math? I mean, in real life, we might care. Like, yeah, I care. As a teacher, I care.
Well, why are we saying they're going to abandon mathematics altogether?
Well, that's what it tells us. It says if they're not ready for the level of abstraction involved, they may abandon the study of math altogether.
Well, what if they really like geometry?
Well, it's telling us that I guess they're saying that they're going to be so emotionally scarred by not being able to handle this that they're going to.
That's why I'm saying it's weak. That's why I'm saying it's weak.
Oh, I get. Okay, yes, yes. That's a point. Like, what if No, you're right. So, how can we strengthen? There's a couple of things that we throw out there. So how can we strengthen this argument? We can strengthen it by helping us close that gap of that hole of, one, we don't want students to abandon math, or two, and so we can strengthen this argument by showing that the opposite of what Zach said, because for our argument to be secure, we don't want to be like, oh, they're really not going to abandon it. We want to say that most students, so if I was going to predict an answer here, I would say most students that would be taught this today would abandon math. If that was true, would that be a good strengthener for why we must make sure they can handle the level of abstraction involved if most students were going to eventually abandon math because of it?
My prediction was make sure that they understand the foundations. or like only select the few that can like make sure that the ones that you do teach can handle it.
But would that strengthen that we must handle the level of abstract? Because we're just strengthening the conclusion, and the strengthening the conclusion part is that before we even attempt that, we need to make sure they can do this.
Mm-hmm.
Because what if only one person couldn't handle it? Would that really strengthen this argument? If only one out of 100 students, only one was going to abandon the study of math together, would it be worth putting 100 people through a abstraction class before calculus? Do you want to go through that class if you're like one of the 99 students that can already do it? No, I'd be like, no, please don't make me do this. So this is an easier question, and you're probably like, why is she going into so much detail? But just to slowly practice finding the flaw and predicting something to fill it, so when we get to harder ones, we really can realize like, how are we filling this flaw at? So we had a couple different answer choices. We had A and D, and then someone just said that B was tempting. So let's go ahead and go over these. Why is B wrong, Angelica?
Is it because it's saying it talks about level of mathematics that are concrete, which like we're not talking about the actual math classes being concrete. We're talking about the understanding should be concrete.
Oh, well, and this is saying like only, so it's saying only those parts of the university level math that are the most concrete should be taught. Well, that's cool, but what does that have anything to do with handling the level of abstraction involved? Nothing. It's irrelevant. It's completely out of scope. Like, it's like, okay, cool, only these things should be taught. But that doesn't mean that the abstraction should or should not be taught.
Okay.
All right, so Nicole, what did you like about D?
I liked how it said that the students are likely to learn effectively only when the application of mathematics to concrete problems is shown.
Okay, was there any other answer choices that were tempting to you?
I thought A was a little tempting.
All right, so this is like what this class is really going to focus on, is how do we pick the best answer? So let's go ahead and get rid of B, C, and E, and let's really focus on the differences between A and D. So let's say we narrow it down to these two. So whenever I narrow it down to two on a strengthen or weaken question, and I, instead of like just going up and like rereading and rereading the answer choices, I just go back and realign myself with the conclusion. So we're trying to prove that we must make sure they can handle the level of abstraction involved. And I want to say like, well, why do we want that? Which one of these helps us get there? And so on strengthen questions, do we want strong or mild wording?
Strong.
Strong. So let's pay attention. Let's look at these two answer choices and see which one is stronger. So A says only is a strong word. So only those who, without losing motivation, can meet the cognitive challenges that the new intellectual work involves should be introduced to it. So only those who can meet the cognitive challenges that new intellectual work involves should be introduced to it.
So it sounds stronger when it says only, but I think what I got caught up with that one is the cognitive challenges, because it doesn't mention anything about that.
See, Nicole, for me, D says it's saying for D that they should be aware. That's the difference. Should be aware. Well, maybe they're not. Maybe they are. Maybe they aren't. But it doesn't mean they should be aware. Should be aware is kind of like a little in between iffy.
Okay, so there's flaws. There's things I don't like about both answer choices. So Nicole picked up on one on A that I agree with, and D you did as well, Zach. So let's start with, I think D's easier to break down first. So teachers who teach university level math to pre-university students should be aware. Absolutely. So these students should be aware of the students that are likely to learn effectively only when the application of mathematics to concrete problems is shown. So the fact that they have to be aware of the students that need this, does that mean that we need to make sure that they can actually handle this level of abstraction before being taught? No, I think that, so that's why D is wrong, where it's like, it sounds good. And I do think it might strengthen it like a little, I mean, I don't think it weakens it at least, but it's not getting us any closer to like, hey, if we're going to do this, we need to make sure that they can handle it. Where D is just telling us that we need to be aware of the problem. It's not telling us to act on it at all. And I agree about the concrete problems. But we have concrete problems here. Is that in our stimulus at all? And then we have cognitive challenges up here. So I was like, I kind of, in my head, I kind of like leveled those out with those two words, but only
I
those.
think abstraction is like cognitive challenge. That's how they're relating it.
Yes. So, but if it's true that only those who can meet the challenges should be introduced to it, if only those students should be introduced to it, does it make sense that if we're going to teach pre-university calculus that we need to make sure that they can handle it? Because this up to here also is I think that conditional statements are a little bit harder too, because it's saying if. So if this happens, so if we teach calculus, then we need to make sure they can handle it. What strengthens the idea that if we teach calculus, we need to make sure they handle it? It's that only those who can actually do it should be introduced to it. So A isn't guaranteeing that we're even going to teach calculus in the first place. It's just strengthening the idea that if we do, we want to make sure they can handle it, and A helps us get there. Do you see that, Nicole?
Yeah.
Awesome. We just spent like 10 minutes on one question, but I think it was good.